Hello everyone, my name is Pompey and today's topic is image segmentation. So, so these are the contents we have like introduction, importance and types and challenges and in the end the summary. So we'll be seeing one by one and first we'll be going through the introduction of image segmentation. So what do you mean by image segmentation? So first, basically, it's a fundamental concept of digital image processing. So it involves dividing an image into multiple segments or regions based on certain characteristics. So the goal is to simplify image analysis and make it easier to extract meaningful information. So as you can see, I have mentioned some of the points. Like image segmentation refers to the process of partitioning a digital image into multiple regions, like based on the sets of pixels. So an image is segmented like for multiple regions. So the goal of segmentation is to simplify or change the representation of an image into something that is more meaningful and easier to analyze. So suppose there's a complex image and it has to be breakdown to simplify it. So segmentation is used. So image segmentation is typically used to locate objects and boundaries in images. So suppose you want to identify an object in like machine learning, you want to know what type of object is that. So to identify that, we need to find the boundaries of a certain object, and it depends on the brightness and intensity of the pixels. So at that time, image segmentation is used to locate those objects and boundaries in an image. So next point, we have like each of pixels in a region are similar with respect to some characteristics or computed properties such as color, intensity or texture. As I said in previous point, so it depends on the color, property, intensity and texture. So if the object in the image has some properties like more intensity or some color differentiation, so based on that it will be detecting. So coming next, adjacent regions are significantly different with respect to the same characteristics. So, so the characteristics are different with the adjacent uh, regions. So that's it. So some applications of image segmentation in medical field. So you can see these of the brain scans. So locate tumor and other pathologies. So measure tissue volumes. So computer guided surgery. So for these kind of medical applications, image segmentation is used. So next we have importance of image segmentation. So image segmentation is essential for various applications including object recognition, image editing and medical imaging and autonomous vehicle. So this including object recognition. So this can be this helps in machine learning models. So image editing, like some of the basic movies and Photoshop uses this image editing, and medical imaging, as you saw in the previous, like to locate a tumor or anything, and autonomous vehicle like Tesla cars, like it uses object detection and the lane in the roads. So it helps in that. So it helps in identifying and separating different objects or regions within an image, like as I said in previous slide. So it helps in separating the objects in an image. So it's the so accurate segmentation allows for more precise analysis and interpretation of images. So this makes the accurate segmentation. So like it helps in analyzing the image more accurately. So this is where image segmentation comes to picture. So coming to the types of image segmentation, firstly we have thresholding, region-based segmentation, and edge-based segmentation. So what is this thresholding is dividing an image into different regions based on pixel intensity values. So suppose some area of the image has more intensity and some area of the image is less intensity. So based on that, this thresholding type of segmentation divides an image. Then region based segmentation, grouping pixel based on similarities in color, texture, or other features. So region based segmentation, as you know, it divides an image. So segmentation is basically dividing an image into different regions. So this region based segmentation divides an image based on the color or texture or the other features, so it depends. So coming to the last type of segmentation, it's edge-based segmentation. So it detects an edge or boundaries in an image to separate different objects. So how do you detect an edge? So like actually there's a whole process to detect an edge in an image or boundaries in an image. So first we will be applying convolution method. So that will be coming in the further topics. So it's basically edge-based segmentation is actually detecting edges or boundaries in an image separate, and it separates the images. So that's it. So we'll be going through what is the threshold-based segmentation deeply. Threshold-based segmentation is a technique, simplest and most commonly used technique. So as I said, if there is more intensity in some part of the image, so it separates the image based on the pixel intensities. So it involves settings as a threshold value and classifying each pixel as foreground or background based on its intensity. So this technique is effective when the object of interest have distinct intensity values. So where it is when it is used is, so suppose there is highly different intensity values between the objects in an image. So at that time it is used. So coming to region-based segmentation. So region-based segmentation groups pixels based on their properties such as colors. So if there are different colors, each object has different colors. So at that time, by different it helps us to differentiate the colored image, based on the color or texture. So this region-based segmentation helps. So it aims to create regions that are homogeneous within a different from each other. So that's what, if two different objects have two different colors, or similar objects with different colors, so that at that time this method is helpful. So coming to common region based algorithm and including region growing and merging approaches. So as we can go to the next slide, this we have edge-based segmentation. So edge-based segmentation focus on detecting boundaries or edges between the ranges. As I said in the previous, it, it segments an image based on the edges, detecting the edges and the boundaries. So suppose there's a this part this it's an image. I mean, just consider this whole thing as an image, and if you consider just this, and it founds this boundaries or detecting an edge, so at that time it separates this part of the image, and the rest of the things are separately. So at that time, if you want to segment an image like that, so based on that, its based segmentation is used popular, and it is one of the most popular edge detection techniques, including Canny, Sobel, and Laplacian so these are the techniques to detect an edge, and we'll be discussing it further. So challenges in image segmentation. So what are all the challenges that image segmentation faces? So image segmentation can be challenging due to variations in lighting condition, noise, and complex object structure. So as you can see, lighting condition means some part, suppose that there's an image, but the image has different objects, but the lighting is uneven, or some part of the object has more lightning and some part of the object in the image has less lightning. At that time, it becomes challenging to segment an object, I mean segment an image. And coming to noise, if there is a blurriness, noise means nothing but it's not clear, the image is not clear, and it's a little blur. So at that time, image segmentation can be really difficult, and even to detect an edge, we should remove the noise. So to remove a noise, certain filters are applied. So later it can be further processed. So and complex object structures. Suppose there are too many complex objects, some various spikes or some different structure is there. So it will be hard to identify those objects. So the choice of segmentation algorithm and parameters greatly affect the accuracy of the results. So these algorithms and these parameters are nothing but we discussed in the previously, like so Sobel and Robert and Pervert, those kinds of algorithms. So these like we should use those algorithms wisely, and where we should be knowing that. And over segmenting or under segmenting can occur, leading to an incorrect intensity. So it's nothing but, so over segmenting and under segmenting can occur incorrect. So the image might probably get disrupt when we use an image segmentation. That's And for the overall summary, it's image segmentation plays a vital role in various image processing applications. To different types of image, we learned like image segmentation is very important. So then we learned different types of segmentation techniques, like threshold based, region based, and edge based. So and we have gone through these three techniques. So and further we had cluster based and watershed and graph based and some other techniques, but we discussed about threshold based, region based, and edge based. So threshold is nothing but based segmentation based on pixels. So region based is nothing but segmentation based on colors and textures, and edge based is nothing but it detects boundaries, detecting boundaries and edges, and based on that boundaries, so it will be segmenting an image. So choosing the appropriate segmentation method depends on the specific characteristics of the image and desired application. So as I said earlier, like we should be choosing the algorithm for a particular image, like wisely, or the image and algorithm might not go with a perfect balance. So that's it for the image segmentation. So thank you.